Hello dear students and welcome to my YouTube channel. In today's video we are going to see a small problem based on bivariate linear correlation. This question is from the topic of bivariate linear correlation. We are asked to calculate the product moment correlation coefficient from the following data. We have the table values wherein x is given as 6, 2, 10, 4 and 8 and y is given as 9, 11, 5, 8 and 7. So we are required to find out the product moment correlation coefficient, and for this we are going to use Carl Pearson's formula. So the Carl Pearson's formula is small r is equal to sigma xy divided by n minus x bar into y bar divided by square root of sigma x square upon n minus x bar square multiplied by sigma y square upon n minus y bar square. We'll be curating our table as per the requirement in the formula. So let us start modifying that. We'll first have the table values x and y as it is in the table. So we have 6, 2, 10, 4, 8. We have for y 9, 11, 5, 8, 7. If you will see that we need total of xy, we will be adding a column for xy. It will be 6 multiplied by 9, that's 54, 2 multiplied by 11, 22, 50, 32 and 56. We need x bar. As you are aware about x bar, it is nothing but total of x divided by n, and for y bar, it will be total of y divided by n. Coming in the denominator, we'll need sigma x square. So we will be adding a column for x square, and that will be square of the values under column x. So first value is 6. We will have 36 followed by 4, 100, 16 and 64. And likewise, we will be needing to add a column for y square. That will be 81, 121, 25, 64 and 49. Let us quickly total these. Now we will move on to the formula. We already have the formula listed here. So we have got sigma of xy as 214, sigma of x as 30, sigma y 40, sigma x square 220, sigma y square is 340. Firstly, we will evaluate x bar and y bar. So x bar is given as sigma x upon n and sigma x is 30. Now n is the number of bivariate data which is provided to us. So we have 1, 2, 3, 4 and 5 pair of observations. So n is 5. So this is going to be 6. Y bar sigma y upon n, that's 40 upon 5, which is 8. Final calculation of small r. The reason I'm specifying small r is because we are going to later on talk about capital R as well, and that is Spearman's coefficient of correlation. Now I'll be first specifying the formula again before making the substitution. So we have sigma xy upon n divided by x bar, y bar, and then we'll have a big denominator which includes root of sigma x square minus n upon n minus x bar whole square multiplied by sigma y square minus n upon n minus y bar whole square. Now let us substitute the values. So sigma xy is 214 divided by n, which is 5. X bar we have got as 6 and y bar we have got as 8. Coming to the denominator part, so we need sigma x square divided by n, and sigma x square is 220 divided by n, that's 5, minus x bar square, that's 6 square, and here we will have sigma of y square, which is 340, divided by n, that is 5, minus y bar square, that is 8. Now all required is careful calculations on the calculator. So 214 upon 5 is 42.80, minus 6 eighths is 48, divided by 220 divided by 5, that's 44, minus 36, and here we got 68 minus 64. It is square here, we have missed on that. In the numerator we have got 42.8 minus 48, that's negative 5.2, divided by, so in the first square root we have 44 minus 36, we need the square root of that, and that is 2.83, multiplied by, here we will have 4 in the second square root, and square root of 4 is 2, so that will be 2. So in the denominator we have got 2.83 times 2, which is 5.66, and we are with the final answer. So minus 5.20 divided by 5.66, we get the answer as minus 0.92. So that's the required product moment coefficient of correlation. So that's all in this video. Do like the video and subscribe to my channel for more videos on such topics. Thank you so much for watching till here. Happy learning.